Hello one and all, I am Dr.Y.Lalitha, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. In today's video, I am going to discuss about the topic resistors connected in series and parallel. So what is a resistor? Why resistors are connected in series and parallel? All those we are going to discuss in this video. So what is a resistor? As I had explained in the previous video, I told you about the passive elements. So what is a passive element? The elements which have the capability of receiving the electrical power is called as passive elements. So examples of passive elements are resistors, inductors and capacitors. So resistor is nothing but a passive element and it is a two-terminal electrical component. Means it is having two terminals and it implements the electrical resistance as the circuit element. So its property is resistance. So what is the property of resistance? To oppose the flow of electrons through it. Resistors, what it will do means, it will reduce the current flow. So why it will reduce the current flow means, according to the property of the resistor, it opposes the flow of electrons. So if we are opposing the flow of electrons, the current flow will be reduced automatically. So if there is a reduction in the current flow, there will be a low voltage levels at the output. So all these are interconnected with each other. So in the most of the circuits, it not only limits with one resistor. So multiple number of resistors can be used in one circuit in order to make it a big circuit or in order to make the flow of charges in a circuit properly. So there are mainly two combinations in the resistors. They are series resistor and parallel resistor. Means connections. How we are going to connect the resistors means they are classified into two types. They are series and parallel. So now let us see about the series and parallel type of resistors. So before going to that, so first let us see about the circuit. So what is a circuit and what does this circuit comprise of? So here, as we are seeing here, this is a circuit. Means it is forming a closed loop and we are connecting the different electrical elements in this circuit. So what are the different electrical elements which we can connect in the circuit are? First, the main thing was conductor. So what is a conductor? So conductor means which allows the free flow of electrons through it is called as conductor, which allows the free flow of electrons. So examples are all metals. So in our generation, transmission or distribution of electrical energy, in general we will use copper as conductor. So we'll use mainly the conductor. In this circuit we'll define it as wire. And source, it may be a voltage source or current source. Source will be there, means battery, nothing but source. Here a conductor will be there, resistor will be there, switch will be there, load will be there. Whatever the load it may be either light or fan or TV or tube light, whatever it may be, everything is load. So a circuit comprises of mainly all these type of elements. So generally in the circuit, if we are starting from one end, the current will flow throughout the circuit and it will end at that end only. Means at which place the circuit starts, that same place it will end. It will end because in the circuit the current will flow. Current only flows in the closed circuit. If at all, if any breakage of wire is there or if there is any disconnectivity in the circuit, the current won't flow in the circuit. Current flow only in the closed circuit. So for that, here, in the closed loop, the current will flow. So next one was switch. So switch is used to either to connect the circuit or disconnect the circuit. So switch is mainly used to connect or break a circuit. Next one was resistor. A resistor is a passive element as we had discussed it before, which means it only consumes the electrical power. It restricts the flow of electrons. It only consumes the power, but it does not generate any power. So the load in the circuit consumes the electrical energy and it will convert into any form of energy like light, heat, etc. So the load can be anything. It may be the fan or tube light or grinder or mixie, washing machine, whatever it may be, it is a load. So now in this video, we are discussing about the resistors connected in series and parallel. So what is the need of reduction of the resistances or what is the need of connecting the resistance in the series and parallel? So why we are going to connect means in any electrical circuit, so different components, as we had seen in the previous slide, so different components are connected in series and in parallel in order to form a different resistive networks. So in the same circuit, sometimes the resistors can be connected in series or some resistors can be connected in parallel. So this connection is called as complex resistive networks. Complex resistive networks or a mixed resistor networks. But whatever it may be, however the resistors are connected, whether it is connected series or whether it is connected in parallel, so at the end, we have to reduce the resistances. Means we have to determine the total value of the resistance. So why we are going to reduce means in order to find out the flow of electrons. According to Ohm's law, V is equals to IR. If we are going to find out the flow of current in the circuit, I is equals to V by R. So R means the equivalent value of resistance. So we should reduce the value of the resistance. So for that, we are going to reduce the value of the resistances, means we have to find out the total value of the resistance. So in order to find out the total value of resistance, calculation of the resistances is very much important. Means whether it is connected in series or whether it is connected in parallel, we have to reduce it and we have to find out the value of the equivalent resistance. So for that sake, we are going to derive the values for resistors connected in series as well as the resistors connected in parallel. So now let us see resistors connected in series. So how we can determine that the resistors are connected in series? So this is the symbol of resistor. We all know that this is the symbol of resistor R. So this is one value of resistor. So here, see, this is one value of resistor. So R1, I had named it as R1. So R1 end of the resistor is connected to the R2 starting of the resistor. Means the end of one resistor is connected to the or is the beginning of the other value of the resistor. So if it is there, then if the connection is like this, then we can determine that the resistors are connected in series. So what is the properties of this resistor? Means there should be some conditions, right? Means for the flow of electrons in the circuit or in order to determine the current, whenever the resistors are connected in series, what are the values? So all those now we will see. So this connection, first this connection is called as series connection, means end of one resistor is the starting of another resistor. Likewise, we can connect n number of resistors. So then how we can find out the R total value? Means R equivalent value of resistance means R equivalent is equals to R1 plus R2 plus so on up to how much amount of resistances we are going to connect, that much values. So R1 plus R2 plus so on Rn. So in this case, means in this value of resistors connected in series, what will happen means, see, if suppose current I is flowing in the circuit. How much amount of the current is flowing in this resistor? The same current will flow throughout the circuit. Means the same I will be flown throughout the circuit. Means the same amount of current will be flown throughout the circuit, means all the resistors in the series connection. Means when resistors are connected in series, the current will be same throughout the circuit. But the voltage value, coming to the voltage value, the value of voltage will be different. Why the value of voltage will be different means, for resistor R1, a value of V1 will be there as voltage drop. So now let us see what is a voltage drop. So what is the voltage drop? So according to the property of the resistor property is to oppose the flow of electrons. So that opposition will be done in the form of heat. Means it will dissipate that energy in the form of heat. Means some amount of voltage is getting reduced. That value of reduction in the voltage is called as voltage drop. Value of reduction in the voltage is called voltage drop. That the value of voltage is not equal for all the value of resistors. So for R1, there will be a voltage drop of V1. For R2, there will be a voltage drop of V2. For Rn, there will be a voltage drop of Vn. So that value of voltage will get varied across each resistor. So in the series connection, the voltage values will be different and the current value will be same. Voltage value is different and the current value is same. That we have to keep it in mind while we are taking the consideration of resistors in series. So whenever the resistors are connected in series, voltage value will be different across each resistors and the current value will be same. So the total resistance value of the system is the sum of individual resistances. So how many number of values of resistors are there? If 3 values of resistor are there, we can determine R total is equals to R1 plus R2 plus R3. If 4 numbers of resistors are there, then we can determine the equivalent value of resistors are R1 plus R2 plus R3 plus R4. Similarly, how many number of resistors we had connected? So the value of resistance is also is the value of same, means R1 plus R2 plus R3 plus R4. So likewise, we are going to determine the resistors connected in series. So this is a small problem regarding the resistors connected in series. So a resistor with an electrical resistance value of 100 ohms, means they had given R1 as 100 ohms, which is connected to another with a resistance value of 200 ohms. That means they had given R2 value as 200 ohms. Here they had told us the two resistors are connected in series. So according to our derivation, R equivalent or R total is equals to, what is the formula? R1 plus R2. So R1 means 100, R2 means 200. So the value is 100 plus 200 is 300 ohms. So this is the formula for resistors connected in series. Next one was resistors connected in parallel. So see here what is happening in this circuit. So if the current I is flowing in this circuit, if it is coming up to here, it is having two paths to go. One path to go here and one path to go here. So then what will happen? The total current, in the total current, some of the current will go here and some of the current will go here. Means what is happening here? Current division is taking place. Means in the parallel circuit, whenever the resistors are connected in parallel, the currents in the circuit are not same. The currents will be different. The value of currents will be different. But the value of voltages will be same in the case of parallel circuits. So voltage is same across all the resistors. So this resistor or any other component can be connected very easily or disconnected very easily because it does not affect any other elements. While connecting or disconnecting, when it is connected in parallel, it is connected individually so that we can remove it or we can add it very easily. But in the case of series, it is connected to the other end, means the previous end or to the other end, so that the connection or disconnection of the resistors will become difficult in the series. But in parallel, that difficulty won't be there. We can easily connect or easily disconnect the values of resistances. So in parallel, so equivalent value of resistance is 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus so on 1 by Rn. 1 by R1 plus 1 by R2. So here R equivalent is 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus so on 1 by Rn. Means the sum of reciprocals of the resistance. Means the sum of reciprocals of the resistance of an individual resistor is the total reciprocal resistance of the system. So now let us see the problem regarding the resistors connected in parallel. So like previously we had taken 100 and 200 ohms in series connection. Here also I am taking 100 and 200 ohms. So here what they had given 100 and 200 ohms resistors are connected in parallel. What is the total value of resistance? According to the derivation, so 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Equivalent value of resistance or total value of resistance, both are same. So 1 by R equivalent is equals to 1 by R. What is the R value? 100 ohms. What is the R2 value? 200 ohms. So if we have taken the LCM, we can find out the equivalent value of resistance. So R total, how much we got? We got 66.67 ohms. So like this, we are going to sort out the problems on resistors connected in series and parallel. So the derivations of resistors connected in series and parallel will be explained after explaining the KVL and KCL. Then you can able to understand very easily how we are going to derive the formulas for resistors connected in series and parallel, which I was going to explain on further videos. Thank you.